the network of networks is cordially inviting you to join in on the explosive information highway. Coming to a PC near you is a communication highway network riddled with information, ideas, insights, and images. To prepare you for your trip on the internet, the following video presents a preview of the navigation tools available and suggestions on how to successfully use the internet. Your host for this program is Tom Benneman. To join us on the internet cruise, you'll need a computer, a modem, a communications package, and a public access provider with the telephone number of a remote host. We'll explore the setup later in this video, but for the first part of this presentation, all you'll need is a good set of ears, note-taking abilities, and more importantly, the curiosity and desire to learn. Here's a taste of what you'll see from this video on your way to the internet cruise. Tom will walk you through the tools and resources you'll need in order to access internet, how you register and get online with internet, answer some of the more commonly asked questions about internet, and show you what's available once you're on the internet highway. And finally, he'll walk you through the actual internet screens you'll be using and show you how to navigate through the internet successfully. Are you ready? Then let's cruise.
The most commonly asked question in today's social circles seems to be, so what exactly is internet? Internet is the name for a group of worldwide information resources. These resources are unlimited and well beyond a simple verbal explanation or even a 60-minute video. But one thing about the internet is it is resources available to you, whether you're a business or individual, available from almost anywhere at any time to anyone. Some people claim the internet is a collection of computer networks. This is true. The computer networks are the medium that gets us to the heart of the internet. They are the hardware. But internet is not just about hardware. It's about the information itself and the people you meet as you acquire and pass on information. Although you don't generally see the people you converse with, and you may or may not meet them, you will get to know them. Because together, you're seeking the same thing, the heart of the internet, the tangible information and resources, but also the intangible benefit of the internet, the adventure, learning, challenges, and communication capabilities. Hi. I'm Tom Benneman, your host for this video presentation on cruising the internet. This video is brought to you by Digital Data Express in cooperation with Netcom Online Communications. It's no secret, the internet is a powerful tool, a vast unmanned network of unlimited information. Many call it the information superhighway, or the giant network of computers, or, as the LA Times calls it, that electronic information pastiche. In reality, it's all these things and more. The internet is about information and resources. To help you better understand how to navigate through the internet and cruise this information, Digital Data Express has put together this video presentation. Their goal is to be your information highway and bring you the teaching tools on how to successfully cruise the internet highway. Corporations and businesses consistently depend on specialists and consultants to keep them up to date on leading trends and strategies. Individuals like you and I need this personal guidance as well. This is what Digital Data Express is all about, keeping us up to date with how to make use of the tools that are out there. Whether you're at home, work, school, or wherever, the internet keeps you connected and cruising for information. The internet makes it all possible from a computer screen. Internet is really about 4 key services that support the infinite number of resources. First, the mail handling service, which receives and sends messages electronically to the correct address. Then there's TELNET, which makes it possible to have an electronic session from a remote computer. Thirdly, there's the data transfer service from one computer to another. FTP, or File Transfer Protocol, is a service you'll depend on. The last key service is the General Client Server Computing Service, whereby a client program can enlist the assistance of a server program. We'll talk about each of these services and some of the resources that use these services in further detail. But these 4 key services are the foundation of internet and the ones you need to be aware of. To give you a quick glimpse of the wealth of information, let's take a quick peek at some of the internet resources. The backbone and motivation for internet is electronic mail, which is a very common mail service. Another major draw to internet is Usenet, which means the user's network. FTP, File Transfer Protocol. The FTP service allows you to copy files from one computer to another. Being involved with internet, you'll hear a lot about ARCHIE, Veronica, Jughead, and even GOPHER. This is a client-server computing program that retrieves information from machines on the internet. And now, on to Veronica. It's designed to help you find Gopher repositories that contain the information you're looking for. WAIS, WAIS. WAIS servers provide another method of finding information spread around the internet. Another interface to many other information repositories is the Webb, or WWW for World Wide Web. This is a hypertext-based tool that allows you to retrieve and display data based on keyword searches. And that's a quick preview of what lies ahead for you as you cruise the internet. The roadblocks? The only detriment is also a positive: the vastness of the internet. The wealth of information, as you've seen, is there. It's getting a handle on the resources available to you to access this information properly. Across the internet, there are lists of access providers, suggestions on how to use everything from email to remote databases, tutorials, lists of frequently asked questions, news groups for beginners. But to access these resources, you have to be cruising the internet. In the interim, you have your pick of many books at your local bookstore. These books range in levels of expertise and are excellent sources of information, and books you should have readily available. To get you really started rocking and rolling, though, we've created this video. Now, before going into the details of what we'll see and partake in our internet cruise, let's first take a step back and look at what makes the internet tick and how we can function within it. I think the easiest way to do that is first answer some of the more commonly asked questions about the internet. Question number one is, how do I get started? Since you're watching this video, I'm assuming you're interested in gaining internet access as an individual at your home or single home office. In which case, you essentially need 5 things: a computer, a modem, a communications program, and the telephone number of a remote host to which you can connect to the internet, plus an account on that computer. For this video, we're using a PC and a 9600 modem. You can use a PC or a Macintosh. It doesn't make any difference. You'll also need a communication software package for your PC that emulates a VT100 terminal. Crosstalk, Procom, or White Knight are all available communication packages. The text and screen design you'll see with these packages is Unix. Now, don't let this computer language scare you. You don't have to become a Unix expert. You'll just need to know some of the key commands to successfully navigate through the internet, and we'll show you what these are later in this video. You'll notice some of the screens you've seen in this video are not strictly ASCII text and look very much like the traditional software packages on the market. Some progressive companies, like Netcom, are releasing point-and-click software programs for Windows and Mac users that will make the internet easier to use. Appropriately enough, Netcom's new software program is called NetCruiser. With NetCruiser, you spend more time actually cruising the internet and checking out the sites rather than trying to decipher your way through a map of text. The colorful and simple graphical look is very much like any software program you're currently using to prepare presentations and reports, etc. Finally, you'll need the phone number of an internet public access provider and eventually an account on their computer. The main number at Netcom is 800-501-8649. They will direct you to the local number in your area. In the interim, you can register as a guest. We'll do that in just a moment. The first thing we do is go into your communications package. In this case, we will be using Procom Plus for Windows. We won't go into all the details of what everything on the screen means. Just know we need to assign a particular connector to the modem. Add Netcom or whoever your provider is to your dialing directory. Our modem runs at a baud rate of 9600, so we select 9600. The data bits should be set at 8, the stop bit at 1, and the parity should be none, and terminal emulation should be VT100. Select OK. This brings us to one of our other more commonly asked questions. How do I gain access to the internet? Access is gained through a public access provider. There are several out there. We've selected Netcom, a full-service provider. Netcom is the nation's 5th largest internet service provider and to date has installed modems to connect customers to the internet in over 30 cities. Netcom was also one of the first commercial providers to support access to individuals. Let's register as a guest with Netcom so we can get a flavor of what it will be like accessing the internet through them. We gain access by dialing a local number at Netcom that patches us into the network. Once you make the connection to Netcom, they respond with Netcom 3 login. You ask, why the 3? This happens to be the computer at Netcom that you're on for this particular host dial-up call. Sometimes it's computer 1, computer 2, up to 11 different computers at this time. At the prompt, type guest, then press enter, and then press enter again to enter a blank at the password prompt. Notice we typed guest in all lowercase. This is part of the rules of Unix. It is case sensitive. Netcom will then ask you for your terminal type. The general default is VT100. Enter the number 1 for VT100. Press enter again. Up comes Netcom's guest program screen. Along the left side are various service information options. These range from telephone numbers to information about how to get an account. It's not a bad idea to save a copy of this information on your PC's hard disk or on a floppy disk by opening a capture buffer or creating a log file on your communication software. And you've done it. You can now cruise the internet as a guest. To register, you simply select the registration option. The information that's needed on this screen is pretty obvious. The only one that may be a bit of a mystery is shell type. Most public access internet accounts, like Netcom, are on Unix computer systems. The Unix operating system offers several different ways to communicate with it, known as shells. You'll notice that CSH is highlighted. This is the default Netcom will use unless you specify something else. Well, the next question, and the one you've probably been waiting for, is payment. If you're paying by credit card, select that option, enter your credit card number and expiration date. Netcom then needs to know what you'd like your login ID or user ID to be. Enter your thought. Netcom will let you know if it's already in use. Netcom will then give you an assigned password that will be your password from this day forward. For security reasons, the password will be a mix of upper and lowercase letters and non-alphabetic characters. After you've entered all the information, Netcom displays a screen to verify someone will be calling you to confirm your account. Then you're back to the main guest screen. And congratulations, you're now ready to cruise the internet. At this point, many people say you're on the net or on the internet. In our registration and guest look at the internet, we were connected via a public access provider, in this case Netcom. Just so you understand the entire internet picture, let's fully address the following question. What are my connection options? As we've mentioned, the internet is made up of a collection of networks that cover the world. These networks contain many different computers, containing a plethora of resources and information. This information is used by a variety of users, from government agencies to universities, to businesses, to public access service providers, to individuals. When you have a connection to the internet, you're connected to the service provider's computer, who is connected to the network. Public service providers like Netcom operate as a full-service facility and carry all these services and the variety of resources that go with them. Or the service provider can elect to provide only those services they wish. For example, many service providers have only the mail service, such as electronic mail, and will not offer the other services such as TELNET and FTP. So you need to be careful when you select a service provider. You want the full service capabilities. The service provider's computer maintains an electronic address on the network and rents its address and hard drive space to you so you can access the resources and information on an as-needed basis. This brings up an important point and leads us very nicely into our next question. What are address and domain? How do they relate? Every computer and every user on internet has their own address. Just like you and I have a post office or a mailbox address, so must every computer and user on internet have an address. The address is an electronic address and always follows the same form. The first part of the address is the person's user ID or login name, followed by the @ sign. Directly following, with no spaces in between, is the second part of the address called the domain. In this case, it's Netcom, the service provider I've selected. And finally, the type of organization they are, which is commercial, so com. And that's it. That's my address. The basic address is user ID @ domain. So you and everyone on the internet has an address. But the question remains, how does the information travel back and forth across the internet? There are basically two ways of moving this information: circuit switching and packet switching. Circuit switching is one-on-one contact using standard phone lines. To move information between two computers, you place a call and the information moves from one computer to the other computer. This type of connection works well with two computers. But it isn't real convenient or efficient for complex applications requiring contact with two or more computers, such as the world of Internet and its many interconnected networks. Therefore, Internet moves information via packet switching and breaks the information down into small packages called packets. With this wide range of hardware, people, and needs, there needs to be a common thread or standard by which everything and everyone must work. This standard is called TCP/IP. To ensure the various type of computers can work together, programmers design all programs around a predetermined set of protocols or rules. That leads to the question, what is TCP/IP? Well, TCP/IP is a large family of protocols used to organize the computers and communications devices into an efficient and workable network. TCP stands for Transmission Control Protocol, and IP means Internet Protocol. IP is responsible for transmitting the information from place to place, while TCP makes sure that the information is working correctly when it gets there. You'll hear a lot about two other protocols, SLIP, SLIP, and PPP. Commercial providers offer not only a host computer for you to connect to, but PPP or SLIP service for customers who require a direct connection to the Internet. SLIP stands for Serial Line Internet Protocol, and PPP for Point-to-Point Protocol. Both of these allow you to use your regular telephone line while making your computer true network participants, complete with a network address. Now you can transfer files directly into your system, as well as the graphical user interface, rather than bringing the file through your service provider, then downloading it to your system. You can also control TELNET procedures through your own computer. The advantages of the newer PPP and the older system of SLIP is you now have direct access to the Internet. Your computer system is physically on the net, and you're able to run various kinds of client programs on your own machine. For example, if you read about a new client that helps you search databases, you'll be able to locate a copy online, download it directly to your computer, and run it there. Without SLIP or PPP, your access to client programs is limited to the ones of your service provider. However, SLIP and PPP are not inexpensive, and for individual use are not widely accepted. But if you do need it for occasional use, they are available via a dial-in basis from your service provider. Now, I know there are still many questions to be addressed, but for now, I don't know about you, but I'd like to actually start accessing some of these resources. How about you? But first, let's just close this little information session with a little history background on the Internet. In the late 1960s, the Internet was set up by government and research institutions as a project from the Advanced Research Projects Agency, ARPA, of the U.S. Department of Defense. This way, the scientists receiving research grants could communicate with one another. Their network became known as ARPANET. In the 1980s, the plan was to link a dozen different supercomputer centers around the U.S. with high-speed lines. The network supported by the National Science Foundation became known as the NSF-NET. The plan was to also include regional networks. In time, some of these regional networks started selling accounts to ordinary people and businesses, not just researchers, academics, and scientists. And thus, the Internet came to be. Today, the users are in the millions, and no one knows exactly how many computers are on it. But we do know we can get access and cruise this information superhighway. So, let's cruise. As we discussed at the beginning of this video presentation, there are several resources available to you on the Internet. These resources are built upon the four main services that make up the framework of the Internet: the mail handling service, remote connection to a host, FTP, the program for data transfers, and finally, the client-server computing relationship. It's important to keep these characteristics distinct, for some of the resources, like ARCHIE, can be accessed through one of two services, either TELNET or the client-server program. Again, this video is an introduction to the Internet, its services, its resources, and how to begin navigating through these resources in order to cruise the Internet. Due to time constraints, I can't possibly teach you all the steps, but I'll get you enough information to get you started. The backbone and the motivation for the Internet, as well as other commercial dial-up services, is electronic mail, or email. At each Internet computer, there are two important programs that provide the mail service. First, there's the transport agent, which works behind the scenes sending and receiving messages. Then there's the user's agent, which is your personal mail program that you'll use to send and receive messages. There are two types of transport agents, which are part of the TCP/IP family of protocols, SMTP and MIME, or MIME. These standards work with two different types of data, text and binary data. Text data is just that, it's text, or ASCII characters, while binary data is anything beyond text, anything that contains dots that make up an image or a picture. SMTP stands for Simple Mail Transfer Protocol and transports text data, while MIME refers to Multi-Purpose Internet Mail Extensions. Most newer mail programs support this standard, and it will allow you to send a combination of binary and text data to any other address that supports MIME. On the user's side, you work with a user agent. There are several popular Internet mail programs. Within Unix, you'll find programs like Pine, Elm, and the standard Unix mail system. Under Windows, there's Eudora, NetManage, Microsoft, Lotus, and the list continues. Each of these allow you to read messages, compose new ones, delete messages, and so on. But you interface with each of them a little differently. The most common user agent is the Unix-based mail. We'll use this for our demonstration. Once you understand this one, you'll be able to move easily into any of the other Unix-based mail programs such as Pine or Elm, or work with any of the popular PC Windows-based programs. To begin, we type the word mail. If there's mail waiting, there will be a display of one-line descriptions called header summaries. If not, it will simply say no mail. We see here, though, that we do have mail. The screen begins by telling us that we have entered mail and that if we have any questions, we can type a question mark at any time for help. We also see that we have 5 messages and 3 that are unread. Now, the one-line header summaries. First, each message is given a number. The message with the greater than sign is the most current message. Before the number, you'll generally find the character U or R. The U means the messages are unread, while the R means they've been read. In our case, we see that 3 messages are unread and 2 of them have been read, but were not acted upon the last time we were reading our mail. Each one-liner tells us first the name of the user ID that sent the message, followed by the date and the time. Next are 2 numbers separated by a backslash. These indicate the size of the message. The first number is the number of lines, the next the characters. Last is the subject of the message. Once all the header summaries are displayed, we see an ampersand on a line by itself. This is a prompt that the mail system is waiting for our response. There are several different commands we can give the prompt at this point. If we simply want to display and read through our messages one after another, we just need to press return. Mail also works off a feature called message list. Each message is given a number, and we can instruct the system to act on commands to one particular message, a group of messages, or a range of messages, whether they're in sequential order or not. If we don't specify a message number, the system assumes we're referring to the current message, the message indicated by the greater than sign. As you go through the messages, the current status changes to the last one read. For example, the greater than sign is on message number 1. This welcome message is from Netcom support. We want to read message number 4 from our friend Brian, whose username is Wolfie. So let's use the message list and enter 4, return. And we see the message about Paris. We opt to save it and read it later. So we enter S, followed by the word Brian. This tells the system to save this message to the file we're going to create called Brian. Now, all messages sent and received dealing with Brian will be kept in this file. To read the next message, we can enter either a plus sign to advance to the next message, or if we want to skip to a particular message, we simply enter the number of that message. For example, we want to jump right to the message about Digital Data Express, so we enter number 3. We see the message displayed, and we read it. Once you start receiving electronic mail, it's easy to end up with a lot of messages in your mailbox. So it's a good idea to start developing the habit of dealing with each message as you read it. If you want to reply to this message, entering the letter R will automatically use the return address of the person who sent the message. Because this message was copied to several other people, we need to make a decision about our reply. If we enter a capital R, the message will be sent only to the original party who sent the message. If we enter a lowercase r, the message reply we're about to create will be sent to every address to whom the message was originally sent. In this case, the message is only sent to Brian. Once we've made our decision, we then type the message, one line at a time. When we're done, we press Control-D to send it on its way. We're back to the original mail screen. We glance up and see that message number 2 and 3 were read last time, but are still on the list because we didn't act upon them. When messages arrive on our desktop, they are coming from your system mailbox. If you quit the mail program and have not acted on the messages you've read, the mail program will automatically save them to your system mailbox or save them to a system file called MBox. Any unread messages, such as messages 1 and 5, are left as is and stored in your system mailbox and displayed in a one-line summary the next time you enter the mail program. We remember the meaning of message number 5 and decide we don't need to read it again, so we enter a D to delete it. However, because we didn't enter a number, the system assumed we were referring to the current status, which is the last message read, which in this case happened to be message 6. If we indeed don't want to delete message 6, we need to enter a U to undelete it. But this undelete is only good during the current mail session. Once you quit, the original command of delete cannot be undone. To indicate that message number 5 is to be deleted, we enter D followed by the 5. To display message 1, we enter a plus sign and read the message. As we're reading the message, we remember we need to send a message to someone else we forgot about, or forward part of this message to that person. To do so, we simply enter the letter M followed by the address of the person we're sending it to. It will ask for the subject. Type it and press return. Then we enter an escape character followed by the letter F. This combination is called a tilde escape. Tilde escapes give you the opportunity to use letters and commands that won't affect the message you're typing. For example, this tilde F command instructs the mail program to include the message you've just read into the new message. If you wanted to use a different message than the one you're reading, just enter tilde F followed by the number of the message. We can see the screen read interpolating 1. This tells us that mail has copied message number 1 to our new message just by entering tilde F. Another alternate is to enter tilde M instead of tilde F. This will do the same thing, except that each line of the included message will be prefaced with a tab character. When the person reads your reply, the included text will be indented. There are several tilde escapes. We won't go over all of them, but let's use a few of them while we create this message. For example, by entering tilde E after tilde F, we start the text editor. We'll be able to change or edit any of the other text in the message. Unix won't allow us to use the backspace command, so tilde E is the next best thing to modify existing material. Now, you need to know how to use the text editor. We don't have time to go over the details of the editor, but it is available to you while you're using the mail program. The easiest use for tilde E is if we want to delete the old header information from the included message. Another useful tilde escape is tilde H. This tells mail that you want to modify the header lines of your current message. Each one will come up. If you don't want to change them, just press the return key. If you knew the particular header information you wanted to change, you can go directly to that item rather than going through the entire list by using particular tilde escapes. To change the To section, use tilde T followed by the new information. Use tilde S to change the subject, tilde C to enter the addresses of the recipients who are receiving copies of this message. The tilde escape B is for specifying if you want to send blind copies to anyone. When we're finished with this message, we want to format the mail message. Unix has a command named FMT that reads data, and line by line, it formats it to be as close to 72 characters per line as possible. It will not change spacing at the beginning of a line or in between words. To format the message before you send it, enter the ~escape vertical mark FMT. To check it, use ~P to display it. To send it, press Control-D to send the message on its way. We quit the mail program by entering Q. Once you've read this message or messages, try to remember to act upon them immediately. And those are some of the real basics for cruising through the Unix standard electronic mail program called Mail. The second internet service we spoke of was TELNET. With TELNET, you can connect to a remote computer, making it as easy to use a computer on the other side of the world as it is to use a computer down the road. The job of TELNET is to connect your local computer to a remote internet host. Everything you type at your keyboard is passed on to the other computer. Everything that the other computer displays is sent to your computer and appears on your screen. The end result is that your keyboard and screen seem to be connected directly to the other computer. To start TELNET, you have two options. Type TELNET. Press return and then type open, followed by the address of the remote host to which you want to connect. Or you can enter TELNET, followed by the address. For example, there's a host at the University of Michigan that provides up-to-date weather reports for any location on the planet. Its easy-to-use interface guides you through the process of selecting a city or a location, then viewing the weather report on screen or downloading it to your computer. The name of this computer is Downwind SPR UMich for University of Michigan HEDU. When you connect to this computer, you also need to enter a port number. Some computers require them, others do not. In this case, it's 3000, and you enter it at the end of the TELNET command. Now we're in the weather program and can access the state or city we're looking for. To find out just how to use this weather program, we enter an H. Now we're in the main menu and select a 1 to give us the U.S. forecasts and climate data. Return. Now it's asking for another selection. We're looking for a particular city. In this case, New Orleans. But the program is going to want to know the 3-letter city code. I could take a guess at what it might be, but let's ask the program to display the city code first. Then we can enter it right the first time. By selecting 3 and entering LA as the 2-letter abbreviation for Louisiana, we see a screen telling us the 3-letter code for New Orleans is NEW. So now we can select 1 with a return and enter NEW for New Orleans. And there we have it, today's weather forecast for New Orleans. To exit, we enter an X and return. The netcom prompt is now seeking another command. Since we're in the TELNET program, let's check out a few more of the resources available to us. One book you definitely will want to pick up is the Internet Yellow Pages. This lists all kinds of different programs. For example, if you're a sports fan, you can get the day's schedule of your favorite Major League Baseball team. We type in TELNET, followed by the address culine.colorado.edu 862. Specify the team you want, and you get today's schedule. Let's check out this year's favorite team, the Giants. Enter SF for San Francisco. And there it is, the upcoming Giants games. To quit, we enter Q and return. And we're back at the netcom prompt. For the game schedule of your favorite NBA basketball team, the address is the same, only the port number is 859 instead of 862. And the TELNET cruise continues. You can type Control and the right bracket sign at any time during a TELNET session, and the remote connection will pause and give you the TELNET prompt. You can enter any Unix commands at this time and then press return to resume your TELNET connection. To exit a program, use the recommended exit technique they have listed. Or if you get stuck, just enter Control, right bracket. This will get you to the TELNET prompt where you can then enter close. This command will close the current connection. To open another, simply type open. For a list of other TELNET commands, you can enter the question mark character. To exit the TELNET at any time, simply type quit at the TELNET prompt and you will exit TELNET. To see what else is available on TELNET, you can look at the Internet Resources list in the back of several of the popular Internet books or browse through the Yellow Pages directory of the Internet. For example, maybe you're a video game fanatic or like to play cards. The directory tells us there's a Windows-based card game. It states that it can be found via anonymous FTP and gives the address and path name. FTP is another service we introduced to you at the beginning of this video. This service is called FTP, or File Transfer Protocol. Like most Internet services, FTP uses the client-server relationship, the other key service that makes up the Internet framework. The client program, called FTP, is connecting to a server program on the remote computer. When you copy files from a remote computer to your own, you are downloading files. When you copy files from your computer to the remote one, you are uploading files. To use the FTP program, you enter the FTP command and specify the address of the remote host to which you want to connect. Again, you can do this in just 2 commands, or just 1. We've already entered FTP and have the FTP prompt, so type open, followed by the address of the remote host you want to connect to. In our case, we've been told it's rtfm.mit.edu. Once the connection is made to the remote host, which sometimes takes a while, you'll see a message like this. The first line tells us the connection's been made. Now, sometimes the name of the computer is different, but no need for alarm. Such aliasing is fairly common in the world of anonymous FTP because systems managers are constantly changing computers. But the address is the same. It just happens to physically be a different computer. The second line tells us the name of the FTP server and the version of the FTP software this server is using. And finally, the last line of the message is a request from the FTP client program, asking us what user ID we want to use to log into this computer. FTP's assuming at this point that we want to use our user ID we logged on with, in this case, Tom. However, in most cases, you want to log in as anonymous, so we don't have to mess with having a specific password. So we enter the name anonymous and press return. The FTP server has approved this user ID of anonymous and now wants us to enter our password. The password will be our mail address. When we've entered it, the screen will come back with a message that says access restrictions applied, followed by the FTP prompt. This means we've been accepted and the first part of FTP is complete. We've connected with the anonymous FTP host that has the file. Now, connections won't always happen the first time. For example, the first time I called this particular host, it was in the middle of the afternoon on a Monday. It came back with a reply saying it was busy and suggested I call back or try one of the other options. The best thing to do is then try again later. To stop FTP, wait for the FTP prompt and type in quit. We then move to the second part of FTP, the downloading of the file. First, we need to move to the directory that contains the file. We enter CD to change directories, then the file path name. Next, we turn the hash option on by entering the command hash. This tells the FTP program to display a numerical character called a hash mark after each data block is transferred. Now, you can watch the progress when you're downloading a large file. To get that file, we type the command get, followed by the name of the file. In this case, it's folklore-FAQ. Once entered, we see the following message. 200 port command successful. 150 opening ASCII mode data connection for folklore, FAQ. At this point, the file is being copied to your computer. Once the copy is complete, you'll see transfer complete. Let's say we want to transfer another file, but this one is an image. By default, the FTP program assumes that it's working with text files. Before you enter the GET or MGET mget command, which is the multiple get command for more than one file, you need to change the representation type, which is just a fancy term for either binary or text file. All you do is enter the command binary. You will then see 200 type set to capital I. The capital I stands for image. Again, we want to turn on the hash command so we can see and watch the file downloaded. Whenever you use mget for multiple files, you might want to turn the prompt option off. If not, mget will poll you each time for a response before it transfers each file. To turn this option off, simply enter the command prompt. And that's it. If you want to check all your current settings of the option, you can use the status command and display them. We've already seen the key setting options in action, so we don't need to review those again. Now, in these FTP examples, we knew the name of the remote host we were connecting to and where that file was located. We won't always have this type of information so easily at our disposal. This is where ARCHIE comes in. Throughout the internet, there are a number of computers called ARCHIE servers that help you find the name of the anonymous FTP hosts which carry a particular file or directory. You have several options when using ARCHIE. You can use an ARCHIE server by entering TELNET and logging on with a user ID of ARCHIE, or you can utilize the program called ARCHIE Server that runs on your own computer. And finally, you could mail a request to any ARCHIE server, and it will mail back your request. Let's start by using TELNET. We enter the TELNET command, followed by the name of any ARCHIE server you want to use. In this case, let's use unl.edu. There's a table in most reference books that lists all of the public ARCHIEs, or once in ARCHIE, you can use the server's command. Once you're connected to an ARCHIE server, it requests a login name. Enter ARCHIE. Some will also ask you for a password, in which case you enter anonymous. Then you'll see some opening messages and the ARCHIE prompt, unless the server is currently busy, in which case the screen will come up and tell you the server is currently at the limit and give you some suggestions of other servers. You might try one of those. The first thing we need to do is set up ARCHIE the way we want by changing the variables. Once the variables are set, we can enter the commands to tell ARCHIE to begin searching. To change the variables, we enter the show command. There are basically three types of variables: Boolean, numerical, and string. A Boolean is one that acts as an on-off toggle switch. To turn a variable on, use the set command. To turn it off, use the unset command. The pager status determines how ARCHIE will display the output. When it's set, the results will be sent via a paging program that displays the output one screenful at a time. If it's off, all the output will be displayed at one time on your screen. So let's turn the pager on by entering set pager. The other Boolean variable is status. As ARCHIE performs a search, it will display the status at the bottom of the screen. It's already set, so we don't need to worry. If it weren't, all you do is type set status. The second type of variable you'll deal with is the numerical variable. There are two types: the auto logout and max hits. Auto logout controls how long ARCHIE will wait for you to enter a command without logging you out. In most cases, it's set at 15 minutes, but a few are as low as 60 seconds. To change this, enter set auto logout and enter the new numeric value of 25. The next variable is max hits, which tells ARCHIE the maximum number of hosts you want to search from. You really need one good host, so the default of 100 is a bit much. Change it to 10. Enter set max hits 10. The third type of numeric variable is string variable. There are several you only need to be concerned with. Mail to, which stores your mailing address. To set it, use the set command mail to, followed by your address. Now, each time you use the mail command, ARCHIE will automatically deliver it to this address. Output underscore format. This tells ARCHIE in what format you'd like to output. You have three choices: verbose, terse, and machine. The most popular are verbose or terse. To set it, type the set command, followed by output underscore. Be sure you include the underscore in the name. Next, Let's tell Archie in what order you want it to display the results of the search. Either you can do nothing, sort alphabetically by file name, by host name, or according to size, largest to smallest, or the time, the newest to the oldest. If you want to reverse any of these commands, simply place an R in front of the variable setting. Let's sort by time. Enter set sort by time. The main function that Archie performs is the searching the internet function. So let's specify how we want Archie to look for a match. When you know exactly what you want, set search at exact. If you enter sub, Archie will match all items dealing with the keyword, regardless of whether it's upper or lowercase. If you want to limit the match to only uppercase or only lowercase, enter the search called subcase. The regex search allows you to use what is called a regular expression to tell Archie what you want. This can be a complex search, so you'll want to use the command help set search if you want more information. Finally, each of these searches can be forced to look only for exact matches by entering the word exact underscore before the type of search you want to conduct. This tells Archie to start searching for the specified pattern exactly. If that fails, then it will try searching for the next closest, which is called the substring. Now that we have all the settings, we can perform the search by entering the command find, followed by the pattern you want Archie to locate. However, if we knew what we wanted but didn't know the name of the file, Archie also maintains a second database that contains short descriptions of thousands of programs, documents, and so on. This is called the Software Description Database. To search this database, you use the command whatis. Archie will search this database and display all the entries that contain the word you specify. Each entry will show you a description and a file name. Now you know the name of the file and can use the find command. Whatis is a wonderful tool when you don't know the name of a file. It ignores the upper lowercase rule and will provide you with quite a few options, a few that have nothing to do with your search. But remember, it is not a search of the full Internet Archives database and will be shy quite a few entries. To use the command help in Archie, just enter the help command followed by the name of the command you need assistance with. To display all the help commands, enter a question mark. If you have the pager variable turned on, all the help commands will be displayed using the paging program. When you see the help prompt, you can enter one command after another. When you're finished, type Q for quit. This will get you out of the paging program. Press return twice, and you're back to the Archie prompt. If you'd like to know everything about Archie, you can look at the online manual by using the man command during your Archie session. Mail it to yourself when you're down, and now you have your own Archie manual. At the beginning of Archie, we mentioned there were 3 ways to use Archie: TELNET, which we just went through, and by using an Archie client or via mail. Let's look at using an Archie client. This is the preferred way to use Archie on your own computer. You do your search with an Archie client just as you would use Archie through TELNET, only the Archie client lets you use all the standard Unix tools when you're working with it. Plus, it saves the output to a file named RFC. When you're searching up your Archie client, instead of entering the set commands, you can use Unix commands. To use sort by time, just enter the -T option before entering the file name. To perform an exact search, you'd use the -E command. However, an exact search is a default for the Archie client. But if you want to do an exact search combination, just enter -E followed by the -S command. -C will search for case-sensitive substrings. -R will search using a regular expression. To send the search to another program or Unix command for further processing, enter -L command. Much like set output _ format machine in TELNET Archie. The -M option has the same effect as the set max hits. When you use the Archie program, it connects to the Archie server whose name was specified by your system manager. To check it, enter Archie-L. The one to know is -V, which displays the word searching, so that you know that something is still happening. If you don't have access to an ARCHIE client or access to TELNET, the next option is mail. Simply send a message to the user ID ARCHIE at the address of one of the ARCHIE servers. In the body of the message, use as many ARCHIE commands as you want, with each one on its own line. The first command you should use is set mail to. This way, ARCHIE has your correct address. The last command we suggest using is quit. Once you receive your response from ARCHIE, you can send a message to an anonymous FTP mail server to retrieve the actual file. Once you start messing around with FTP, you'll find that you need to know something about files and directories and basic Unix commands. We'll go through a few of the basics here in this video, but it's not a bad idea to consult a good Unix book. A Student's Guide to Unix by Harley Hahn is an excellent source. Unix works with files. To them, a file is a collection of data. This data can be any type, such as programs, documents, images, and so on. Each file is given a name. Unix file names can consist of letters, numbers, and certain punctuation characters. Unix distinguishes between upper and lowercase letters, so you need to be specific. Unix organizes these files into directories. A directory is a special kind of file whose only purpose is to act as a repository for other files. You'll see a real hierarchy with Unix files and directories. In fact, directories contain other directories. In drawing it out, the Unix system starts to resemble a tree with branches and sub-branches growing from the main trunk. The second directory is called a subdirectory. The first directory is often referred to as the parent directory. Each Unix computer has one main directory that contains all the subdirectories and files on the system. This main directory is called the root directory. Now, within the root directory are a number of subdirectories. Within these subdirectories are other subdirectories, and so on. When we're writing a directory, we start with the root directory, and then each directory that we must pass through in order to reach the ultimate branch. The root directory is indicated by a single slash character. Then each of the directory names are spelled out. A description like this is called a path or path name. Like most people, you may soon come to realize Usenet as one of your favorite parts of the Internet. Usenet is a collection of discussion groups involving millions of people from all over the world. Each discussion group is centered around a particular topic. There are over 5,000 different discussion groups. Usenet, contrary to popular misconception, is not news, but rather discussion about topics of interest ranging from jokes to politics to travel. The confusion comes because so many of the terms are centered around news terminology. For example, to read Usenet articles, you use a program called a newsreader. This acts as your interface. There are several newsreaders. We're going to show you a program called TIN. You start the program by entering TIN. The first thing TIN does is read your news RC file. This file is created by the TIN program the first time you read the news. Initially, it contains all the active news groups. In time, you're going to want to unsubscribe to most of these and pick up only the discussion groups you're interested in. Each time you enter TIN, anything new is shown from your news RC file. Here you're asked whether or not you want to subscribe. If you don't want to see your news RC file when you start TIN, you can begin the program by entering TIN-Q. This will do a quick start and bypass the news RC file. If you're interested in reading only one group, you can enter TIN and just the name of that group or more than one news group. Or use the command -Z with TIN, and you'll see only the new articles that have been posted. To actually start reading, first select the news group you want and press return. TIN then shows you a list of threads. Threads are a series of follow-up articles to an original posted article. Pick the one you want to read first and press return. Each article is divided into 3 parts: the header, body, and signature. As you're reading the article, you'll see a lot of basic commands we've already talked about. In addition to reading, you can also post articles. To do this, press F to post a follow-up. A lowercase f will include the text of the article in your follow-up. The uppercase F will not. TIN will automatically set up the header and start your text editor for you. When you're finished, Quit the editor normally and TIN will regain control. Then you need to make a selection. Quit, edit, spell, or post. If you don't want the article to be a follow-up, enter the W command for write at any time during your Usenet session. Then enter the subject of the article and proceed to write your article. When you first start posting articles, you should send them as practice articles to misc.test. As you're using Usenet and other programs, you'll probably run across a few terms that are unfamiliar to you, but ones you'll need to know as you cruise the internet. First, there are three words: foo, bar, and foobar. Foo basically refers to something without a name, and foobar means two things without a name. Another term you'll frequently encounter is flame. This refers to a follow-up article in which someone says something critical about someone else. Someone's been flamed or is flaming someone. And those are the basics for reading and posting Usenet articles for your news group or news groups. Then there's Gopher. If we could only use one full-service program, this would be it. Gopher gives us access to many of the internet resources in an easy-to-use interface. Gopher is a client-server program. To run it, you use the Gopher client and tell it what you want. It turns to the Gopher server to ask for information on your behalf. And you can count on Gopher. If it means getting the information from a different server, making a TELNET connection, or downloading a file to get the information, consider it done. Under Unix, all you do to activate Gopher is enter the Gopher command followed by the address of the server you want to use. For example, let's say you and your friend are taking a business trip to Spain at the end of the month, and you want to check with the travel advisories for some basic information, such as passports, crime rates, address of the closest embassy in Barcelona. So, where do you start looking? Start with a public Gopher server, preferably the one closest to you. I'm going to use the one in Minnesota. So I enter Gopher and the address, consultant.micro.umn.edu. Now once connected, you're using what is called Gopher Space. The main menus look pretty much the same regardless of which Gopher server you happen to be using. The name of the server followed by a list of choices. We'll want to take a look at Travel Advisory. Your current position is marked by the pointer. To jump to a particular item, simply enter the number and press Return. After each selection, you'll see a symbol telling you what type of resource it is. The slash means the item represents another menu. The period indicates a text file that Gopher will display one page at a time. The tel command means Gopher will initiate a telnet connection to a remote host. Another symbol is CSO, surrounded by arrows. This means a server that contains information about people at a particular organization. The next symbol is the question mark with arrows. This means a database you can search by entering one or more keywords. Each of these searching commands will give you a menu that asks what you're searching for. If a search works well for you, you should use the command A when the search is done. This will save the search, not the contents, to your bookmark list. Whenever you want, you can jump to your bookmark list and select this exact search. We see we can do a general search to a current advisories directory or file transfer archive. Let's enter item number 1 and return. We're headed towards Barcelona, Spain, so let's start with that. It gives us back to more of a general Spain directory, so let's use that one. We enter 1 and return and get a counselor information sheet with information on quite a few of the areas we're interested in. To get to the next page, press the space bar. To go back a page, use the lowercase b. To get back to the main menu, sometimes you can press M. Other times, such as in this case, enter a Q and you'll get back to another set of instructions. Once a file is displayed, you can mail it, save it, download it, or print it. Now, let's download. Because we're running through a host computer, we can't save it directly to our computer. With the new NetCruiser software, you'll be able to do so. So in this case, let's download it to our computer. Enter an uppercase D. A menu appears asking you to choose which transfer protocol you want to use. Select Z modem, and Gopher will take care of the rest. Another way to do a search through Gopher Space is by using Veronica. She will search all the menu items for specified words. To find Veronica, look for a menu item. Many times it's under Other Gopher and Information Servers. Start with the Gopher command. We see there is an item called Search Gopher Space using Veronica. So we enter 5 return. Let's use University of Manitoba. Enter the word we're searching for. Let's continue getting information for our trip to Barcelona. Only this time, we want to find some things to keep us entertained on the flight. Golf jokes, that's what we need. But first, once you find Veronica, place it in your bookmark list by using the A lowercase command. At any time, you can use the V command to display this list and then select Veronica. After you give Veronica the keywords to search for, she'll search all of the known Gopher Space for menu items that contain the words selected and display them in a menu. The best method is to be as specific as you can. If you know you're looking for golf jokes, enter both these words. If you enter just golf, the display will show anything from courses to instructions to history to lessons. The search is just too big when we know we're looking for golf jokes. If there's a particular relationship you don't wish to see, you can use the command not. The nice thing about Veronica and Gopher is the orientation. Getting around the menus is very similar. Then there's Jughead. As you know, Veronica searches all of Gopher Space. Jughead does the same thing, only the search is confined to a particular area within Gopher Space. The procedure is the same, only you'll find many more Jughead servers than Veronica's. Jughead is particularly useful when you're interested in searching for particular books or universities. Instead of telling Veronica to search for book asterisk LIBRAR asterisk, you can confine your search to a particular university with Jughead. Then look for the particular library and books. To search large amounts of data thoroughly and quickly, you can use WAIS, W-A-I-S. Based on the client-server relationship, all you do is select one or more sources and tell WAIS what to search for. It will find the information you're looking for. The WAIS client is called SWAIS. To start, TELNET to one of the public clients. You'll need to log in as WAIS. Provide the rest of the standard, critical information, and you're ready to check out WAIS. WAIS will do the search and organize a list that prioritizes the best matches first. The second column tells you how well each item was matched to your keywords. To save your sources, use S. To mail the results, use M. Try a new search by entering W, or before that's done, you can redisplay the results of a previous page with an R. And that's all there is to WAIS. Another popular internet resource is Talk. The Talk program allows you to connect your computer to someone else's computer and then type messages back and forth and carry on a conversation. I'm heading to France for a trade show conference in a couple weeks, and I'd like to know where to go for the best food. Now, a friend of mine travels there a lot and knows the best restaurants. So I enter the Talk command and Sam's address, sam@tsi.com. The program will send a message to Sam's computer. At the other end, Sam sees a message stating there's a connection request and gives my address. All Sam has to do is follow the instructions and enter the Talk command and my address. If Sam is logged in but just not responding, the system will let me know by saying, "Ringing your party again." The Talk program will keep sending Sam the message every 10 seconds. Once Sam responds, I can start talking. Both screens are split in half. We talk in the upper half. The other person, Sam, is in the bottom half. We can both type at the same time. The backspace key is active. But if you make a mistake, it's faster to use Control-W to erase the entire word and Control-U to get rid of an entire line. To sever the conversation, you can use Control-C. But try to maintain good manners and say goodbye first. There are several abbreviations you can use. Goodbye is the typical bye. or by question mark if you want to ask if it's okay to end the conversation. The command 00 can also be used, meaning over and out. Another fun one is ROTFL, meaning rolling on the floor laughing. When you're talking, you can also use smileys to help bridge the gap of face-to-face. For example, this is a smiley face. To wink, to laugh, to show indifference. If you turn the typed smiley sideways, you can actually see where the idea of smileys came from. There are times when you won't want to receive messages. In this case, enter MESGN to turn it back on MESGY. Now, this was a conversation with one person. You can do the same thing with groups of people by using IRC, or Internet Relay Chat. A couple of things you need to know before actually joining a group conversation. Most group names start with a number character, and people generally use nicknames instead of their real name. Because of the number of people talking, the screen will look different. You'll be entering your message at the bottom of the screen. The rest of it will be filled with the chatter of the other talkers. To display a list of all the channels, type /list. All the channels will be displayed. If you want to make sure the list is more manageable, enter -MIN followed by a number. Let's keep our list choice to only those groups with 5 people talking. And here's the list. To join Hot Tub, we enter /join number hot tub. From now on, everything we type will be sent to that channel. Excuse me. As you're typing and you decide you want to tell someone what you just did, like cough, just enter the me command followed by what you did. /me coughed. At the other end, everyone will see my nickname, Geek, I love that, followed by coughed. And these are the basics to IRC. If you want to know who else is talking on this particular channel, enter /who*. To leave this particular conversation or channel, just type /leave, the number sign, and hot tub. Of course, you might want to say goodbye first. Finding someone on the internet? How do you go about it if you don't have someone's address? Well, there's a few ways. If you know the organization the person belongs to, you can use the White Pages directory. Start by looking for a GOPHER server for that organization. Then look for a menu item that contains some type of directory or item that refers to phone book or information sources. For example, I'd like to get a hold of an old classmate of mine. I know she's back at the University of Iowa, so let's start there. Enter GOPHER, followed by the address panda.uiowa.edu. So I enter 3 for online information services. And sure enough, there's a listing for phone books for both students and staff. From here, there's access to several categories of White Pages directories. Now, if you know the person's user ID and address, but want to know more about them, you can always finger them. Finger them, the internet way, not the fingering we learned as children. Just enter the finger command followed by the person's address. For example, you met someone at a party the other night. You got to talking about internet, and he gave you his address. Finger wolfie@netcom.com. Now, since Wolfie happens to be at the same computer, we could have entered just Finger Wolfie. You can also use Finger to see the list of users logged into a particular computer by entering Finger @ and the address of the computer. You can also use Finger to find out trivia or trivial information, such as the state of a Coke machine. Me, I like to check in on the chart listings of the top songs as ranked by Billboard magazine. So I finger BUCKMR @RPI.edu. Last but not least, let's take a look at Webb. The World Wide Web is the be-all when it comes to simple, easy ways to find and use just about any type of data. All you have to do is know how to control display text, how to tell your browser to follow a link, and finally, to be able to specify how you want to search an index. Let's start. We'll telnet to one of the public browsers, telnetinfo.funet.fi. The welcome message appears, giving us some starting options. We can view by subject, type, or customize our own page. Webb is based off hypertext, so you can follow any of these links. All you have to do is enter a number and follow the instructions on the screen. At this point, we can move on to new choices. It's like following a trail, just follow the commands. Webb is one of the programs you really need to just keep experimenting with. The key is to use a browser and take advantage of all the links of information available to you. And that pretty much sums up the basics behind the key Internet services and resources. Now that you understand the foundation of Internet and how to begin navigation through the Internet, cruising the Internet will become a daily part of your life. Making it even easier is point-and-click software like Netcom's NetCruiser. Now, you just saw how to navigate through the key resources via your host dial-up connection. With NetCruiser, some of these commands will be eliminated for you to simply click on the program you want. If it's Gopher, select the Gopher head here, and up comes a map. Choose a state you'd like to connect with, and then you'll need a selection from a server for that area. From there, navigation inside the program is very similar. And the cruise continues. The same type of easy navigation with buttons for FTP, Telnet, Finger, Mail, Usenet discussion, and posting of articles. Well, we've run out of time. I hope this has been a successful venture for you, and I look forward to hearing from you on the Internet. Thanks for joining us.